Hello again everyone, welcome back to ptet.chemistry channel. So this is the 6th of 10 video series on these series infographics that are provided by Cambridge Assessment International Education. So they were provided for free on the Resource Plus website from the examination body during the pandemic period in their bid to help learners to try and see this topic connection, which is what I'm going to do here. These are by no means an overview of your syllabus or specification. For that, you always have to refer back to your curriculum materials. So what this is really to just show you the links between the topics, and along the way I'll outline you where you can find the relevant information in my topical playlist for A-level topics that are suitable for 16 to 18 years old chemistry learners wherever you are in the world. Irrespective of whether you're doing the A-level for the British curriculum, or doing for example, the HSC, the high school certificate for the Australian curriculum, or if you're doing the international baccalaureate diploma, the IB, which is very common internationally. Okay, so this is not a tutorial video. For that, you can skip this video and go straight to my other topical playlist, or a full component paper tutorial if you are doing Cambridge International A-level or O-level. But if you're doing any other examination body, feel free to browse through the topical playlist, because they'll be really useful to you regardless. Okay, that's why they've been sorted out in topics. In this video, it's about acid and bases. So you have covered them in, I don't think I talk about pH there, but if you have a pH scale of, like, let's say 7, you will have known that as what you call neutral, and then you say going lower than 7 is acidic regime, going higher than 7 is what you call the basic or the alkaline region. Okay, we talk about acid being a proton donor, so it donates H+, the base being a proton acceptor. Okay, when we talk about acidic regime and basic regime, people forget that neutral would mean that your number of H+ is balanced out by number of OH-. So in neutral water, it has H+, it also has OH- ions, but the number of ions are balanced out. Their concentration are equal. Whereas for acids, your H+ it's greater than OH-. There are more H+ than OH-, so it becomes acidic. Okay. Whereas for alkaline, you have more OH- than H+. That's why they become basic. It's not just OH- alone. When you think about it, you cannot have a cation without an ion, because they don't balance out, right? When you just started out from water, H2O. And most acid and bases we're talking about, they are dissolved in water. That's why the definition of acid is a substance that dissociates in water to give you H+. Okay, Bronsted-Lowry acid specifically say acids are proton donor, but the general definition of an acid is a substance that dissociates in water to give you H+. Bronsted-Lowry acid says acids are proton donor. Same thing for base, a substance that dissociates in water to give you OH-, and OH- is negatively charged. It likes to accept H+. That's why Bronsted-Lowry base definition for base is a proton acceptor. Okay. So here is showing you a pictorial representation of a strong acid, where you have a lot of H+ and the A-. The A- is what you call the conjugate base. Conjugate base is a concept that is covered in the specification and syllabus. So that means you need to know what's going on. The H+ is your conjugate acid. I know it seems funny, but the definition of conjugate base is the species that you get after the acid donates the proton. After the acid gives away the H+, you are left with A-, and therefore that is called conjugate base. There's a strong acid because you get a full or complete dissociation of HA into the ions. As a matter of fact, I don't like what they have done here. You know why? They have talked about equilibrium. You need to be very careful. That would mean partial dissociation or incomplete dissociation, where there is fully dissociate. Okay, or we talk about full ionization into H+ ion, partial dissociation into H+ ions, This is the concept of weak. This is the concept of strong. Okay, so I don't know why they have put that underneath strong acid, but I guess there's no meaning there. This is probably more suited to represent this situation where you don't have a lot of H plus and A minus, but you have a lot of HA lying around because they remain unionized, they remain undissociated because this is an equilibrium. Okay, this is the important mathematical expression to represent calculate the pH given the concentration of H plus. This log is log to the base 10. Okay, they don't show it, which is quite bad. When you rearrange the equation, then the H plus concentration is going to be equal to 10 to the power minus pH. Being able to go back and forth will allow you to calculate H plus concentration given the pH. It will also allow you to calculate pH given the H plus concentration. Just a bit of mathematical trick there. For this calculation, you should refer to the air level, which is an A2 topic, air level topical playlist on Ionic equilibrium. Inside that playlist, you'll find a series of videos where I outline problem solving with specific examples, where we'll talk about pH of strong acid, pH of strong base, pH of weak acid, and pH of weak base. Those are very important. And there's another final one. It's called pH of buffer solution. Buffer, I better spell it correctly. So there's no mention of buffer in this particular video, I guess, in this particular infographics. But again, oh, there is actually. This is blood, HCO3 minus. So your blood is a buffer. You know, human blood is a buffer. Okay, so it has that, but you also have this. Okay, so this is the acid. Carbon dioxide dissolved in water to give you H2CO3. Your blood is mainly water. Okay, but this is the salt, basically the salt in the buffer region, and they help to control the pH in your blood, regulate the pH in your blood. When you add a little bit of acid, so this is the acid added, which one of these will remove the acid added? It will be the HCO3 minus, that is from the buffer. That will give you H2CO3. So when you write an equation to show how buffer works, this is always how it works, yeah? When you add a little bit of acid, now I'm adding a little bit of base. Which one of these will react with the base? Not this, but this, because this has a proton to give away. H2CO3 from the buffer. Your buffer here is your blood. Okay, that's why this is in red. It represents the blood. This is the buffer system present in the blood. Okay, how it responds when a little bit of acid or when a little bit of base is added is that it will do these reactions, okay, in order to regulate the pH such that the pH of the buffer solution remain unchanged with the addition of a small amount of acid or alkali or base. This donates a proton, this accepts the proton, you will get H2O and you will get HCO3 minus. Notice that each time the product that you get is the other component in the buffer. Here, this is what is used from the buffer to react the OH minus. You get the other component of the buffer. Okay? These are pH curve and they are very important in A2 ionic equilibrium. As I mentioned, in the topical playlist on ionic equilibrium is a continuation of the very simple acid and bases you have covered in your air syllabus, because we deal about how can you sketch this kind of diagram. This is the point at neutralization happen. You can calculate those based on your O-level calculation on solution chemistry. Why is this one sharp? That means you can use indicator to monitor this reaction. This is a weak acid and weak base because it starts from alkaline region, and a weak acid neutralization. There is no suitable indicator to monitor weak acid and weak base reaction because you see no sharp endpoint there. So that means the endpoint can stretch across different values of the volume of acid. So that means there's no sharp endpoint. If there's no sharp endpoint, no suitable indicator, because there's no sharp endpoint. This is technically the endpoint. You know, when you do titration, you have an endpoint. Here you have a weak acid and you have a strong base. Here you have a strong base and a strong acid. Here you have a weak base and a strong acid. Okay, this is like the midpoint of your very sharp change in your pH, right? Okay, so strong acid and strong base, the midpoint is roughly around pH 7. Okay, whereas when you have a strong base and a weak acid, your midpoint is roughly just towards the basic region. So you imagine 7 being there, okay, because you have a strong base and weak acid. Whereas here, because you have a weak base and a strong acid, this will be, the midpoint will just be slightly below 7. Okay, so more of this we will be covering ionic equilibrium in an A2 chemistry setting, where you come across water dissociation constant, acid dissociation constant, solubility product, and also pKa. So these are all equilibrium constant, and you would not understand a lot of it if you don't master your chemical equilibrium concept very well. That is to do with chemical equilibrium. We talk about this, and we also talk about Le Chatelier principle. What happens when concentration changes? How would the equilibrium shift in order to go back to being in equilibrium? Very, very important concept. pKa is related to Ka as minus log 10 of Ka, whereas pH is minus log 10 of concentration of H+. So same like what I showed you earlier, H+ can be rearranged as 10 to the power minus pH. Ka can also be rearranged as 10 to the power minus pKa. A little bit of mathematical manipulation. These are the kind of calculations that will be involved in an A-level chemistry setting. So please make sure to check out my topical playlist on ionic equilibrium for all these concepts and many more, which are not covered in these infographics. So yeah, I'll see you in the next video. If you haven't subscribed to the channel, if you like what this channel offers you in terms of the video content and all those tutorial playlists, please subscribe to the channel. Please share them with your friends, your relative, your group chat with your friends, your teachers, and your students if you're a teacher. And yeah, so thank you for subscribing. Get in touch, comment on the videos, or get in touch through the other social media platform, and let me know what you want me to cover next, and I'll think about it. Okay, thank you for watching.